Hello and welcome to the Global AI community. And we are talking about AI upskilling framework today. And also, we have done this one already in August this year, but we got some major updates from Microsoft Ignite a few weeks ago. And today, Carlota and Jose, Carlota is from Microsoft, Jose is from Swiss Life, from the community, also from the cloud advocates. We are teaming together to bring you this kind of updates today. So what we're talking about is about the AI upskilling framework. So about these steps, what Microsoft and also LinkedIn Learning have put together there. On the first one, we talk about understanding. So that's something from all professionals, including leaders, managers, all of the people inside one company, one organization, perhaps, to know what is in AI about, to talk about not the different things, to understand what is the basics and so on. We talk about the application. So on applying, on the second one, it's about prompt engineering strategies to run your copilots, to work on AI productivity, to run the AI in a way you want this one to be. So the third one is about building from low code, but also developers. Today, we will focus more about developers because we see there really great updates somehow on Microsoft Foundry and also on the agent framework. But to be honest, the five will be the second one, will be the training. The next, we do not touch this because it's not that focus on in this kind of series or on this session today, but it's about the machine learning models to run the models on yourself, fine-tune them and so on. And deeply specialization is about like a DevOps. We are talking on the AI ops, but perhaps we will then put this one together only for the third step on this kind of pyramid. So if we're talking about the agentic organization blueprint, we're starting on a Copilot chat. From the left, we got our end user. We see the product, for example, the Copilot, and then we assign a license. We are ready to go. If you move then later, you have a lot of agents that Microsoft provides to us to be productive. So we see here this is a business productivity. Then low code, no code. Studio platform, Microsoft Foundry is the new one that is here renamed, and also a new product without a legacy from earlier. And we run a lot of agents then on customization with whatever agent framework and so on. So that is the whole story. But somehow, perhaps to give you a hint, we will put some links already also in a minute in the chat. But to see where we are going to be, the Carlota will go for AI adoption next.
Thanks, Alexander, for the intro, and thanks everyone for joining today. So, as Alexander just shared, we are going to talk about building today, and especially we're going to talk about building agents. But why we are talking about agents and agentic AI, I like to answer this question with some data, with some numbers. So here's kind of here's a few numbers that kind of depict the current landscape and justify that, you know, agentic AI is the new wave, but you probably know that already. And AI agents are kind of transforming how companies operate. And these numbers you see here are the results of surveys from leading analysts and IT companies like you might recognize Gartner, IDC, or Capgemini. And they say that by 2028, over 1 billion AI agents are expected to be in use. So this is really a pivotal moment for innovation, and technical leaders must really prepare for a future where agents are embedded across workflows, and we are going to see these in more details later. We have, agent adoption is not some distant vision. It's happening right now with 80% and more organizations that intend to integrate agents, agentic workflow within 1 to 3 years. And 40% of enterprise apps integrated with task-specific AI agents by 2026. So AI is not only transforming the business workflows, but also how we build software. So the software development process itself, with over 90% of software engineers expected to use AI code assistant by 2028. So here's the current landscape, I would say, depicted by a few numbers. Again, speaking about why what's the reason to adopt agentic AI nowadays, is addressing a few common challenges which are kind of summarized in this slide. In fact, organizations often encounter several significant challenges when dealing with complex, manual and time-consuming workflows with minimal process automation. And these challenges are things like inefficiency and high operational cost of these manual processes that are typically slower and more error-prone, leading to inefficiencies and increased operational cost. Of course, manual operations leads to human error as well. So manual data entry or other repetitive tasks are prone to errors, which can lead to significant issues down the line. Lack of visibility and control. So lack of, an effective monitoring and management of processes, and scalability issues, because as organizations grow, manual processes can become bottlenecks. So that's why today we are the opportunity for autonomous AI is really growing, and by 2028 we expect that at least 50% of day-to-day work decisions will be made autonomously through agentic AI. Okay, so that's why that's kind of a summary of the current landscape and why we are talking about agentic AI today. And we are going to explore this new frontier in AI in this presentation. But first of all, what is an agent? So an agent is made up of different components, but I would say that the core of it is the large language model. So an AI agent is a large language model powered entity. It might be also more than one model. But to simplify, let's say that the agent is made up of a large language model, which of course can be a small language model as well. And this agent takes digital or physical inputs combined with some instructions. So the other key component of the agent are the instructions the agent developer or designer build to instruct the agent on how to behave, the tone and style of responses it should use, the task it should complete, and all the context it needs to complete the task. So the agent takes these digital physical inputs and then outputs one or more actions to accomplish the goals. And so it means that it plans the actions to take, and then it takes the actions by using tools. Okay, so that's the and these tools, by the way, might be things like actions like sending an email or writing a file or executing an AI generated code, but it might be also just retrieving data from a DB, from a file, or from the web. And another component of agent is memory, but we are going to see these in a bit. In fact, the main capabilities of an agent are three. An agent is able to reason, act, and learn. What does it mean? So reasoning means processing the input. Reasoning for an agent, of course, means processing the input and creating a plan to address the task before actually doing the thing. And this leverages the reasoning capabilities of the latest large language models and enable to get better results. For example, given a user issue described in natural language as input, we can ask the agent to provide a structured JSON that captures the underlying problem after it checked the system logs. So instead of asking the agent directly to execute to fix the issue, we ask the agent to kind of reason and process the description of the issue and output a structured recap of the issue before acting on it. So the second capability is acting. So agents can take a single user request and chain multiple tool calls to complete the task end to end. In the example here in the slide, the agent is able to fill out a work order by populating fields with the name of the issue and the issue details. And once all fields are populated, it submits the form successfully. So this is the action in this case. The other piece of this is learning, which basically is the memory component I was referring to before. So agents can remember past experiences to avoid repeating mistakes. Again, back to this example, when assigning a technician to an issue, the agent recalls that a certain person, like Alex in this example, is unavailable and selects another technician instead. So it can retain this kind of information to avoid repeating mistakes, but also, for example, to offer a better customized experience to a user and to retain some information about the user profile, user preferences, and so on and so forth. Okay, so these are the main capabilities of an agent. And as AI systems evolve, we are kind of moving from interacting directly with a large language model. We started with, just giving prompt to a model and getting responses. The difference here, we are talking about agentic AI, which main difference from the no agent experience is that the model is associated, has access to a number of tools that enable the system to take actions on behalf of the user. And this makes the system kind of semi-autonomous because it can take input from humans, but also from other agents. And this means that agents can work together as well into more complex systems, so multi-agent systems, to complete, more complex more complex goals and tasks. Okay. So where agents are used today, because I've said that, agents is not a future thing. People are using agents already in production. And so AI agents are already making significant strides across various industries, with use cases ranging from travel booking to employee onboarding. And in each of these areas, agentic AI workflows are improving efficiency, accuracy, and customer satisfaction. For example, AI agents can assist with booking business trips, helping new hires on board, or providing personalized customer support. So this technology is revolutionizing workflows by handling repetitive tasks, leaving humans to focus on higher level strategic decisions. So multiple use cases, as the one we just referred to, but also multiple industries. Here we have some example, but of course this is not exhaustive. There's there's agentic AI workflow in healthcare, for example, to accelerate drug discovery or clinical trials. In the energy and manufacturing industry, to enable predictive maintenance and automating supplier coordination. In travel and hospitality, to personalize travel experience, so provide a personalized experience to the user. And retail, of course. Okay, everything is, we have seen all the capabilities of the agents, everything these technologies is able to do, but of course there's challenges as well. There's challenges in the development of AI agents. Again, we try to summarize these challenges in this slide in 4 main categories: knowledge, action, security, and evaluation. So first of all, providing agents with the right context or knowledge ensures they understand the environment they operate in. If they don't have the data, they will not be able to successfully complete a task. especially because large language model has knowledge cutoff, has no access to data behind firewalls. So we need to provide the agent the knowledge, the context it needs to operate. Second, keeping them with the right tools and capabilities enable them to perform the necessary task. Again, the beauty of agentic AI is providing the model access to tools. Otherwise, the model wouldn't be able to, perform any action for the user. And then security is paramount. Agents must have access only to the resources, so the data and the tools they need, and be protected against misuse. And lastly, evaluation is really key and ensures that the tasks are completed correctly and allows for performance optimization. So addressing these areas forms the foundation of effective AI agents. Okay, so building AI agents from scratch has traditionally been a complex and challenging task for all the things I've just described. And there are several factors involved, such as integrating diverse tools and APIs. Nowadays we have thousands of models, we have thousands of tools, and the problem is really integration of multiple models with multiple tools and multiple frameworks. So interoperability is another hurdle, as agents need to work seamlessly across various platforms, and the multi-agent architecture, which are even more complex. We might have agents built with different platforms, and we need to integrate them together. Then we have scalability, which is also critical to ensure agents can handle growing data and workloads. Additionally, real-time processing, maintenance, and error handling add to the complexity of this architecture. Okay, so how to face all of these challenges we just described? We need a standard. We need an iterative pattern to handle the agentic AI dev lifecycle. So just like DevOps brought structure to traditional software development, what we call agentic AI Ops is about bringing workflows, tools, and repeatability to how we build, evaluate, and ship AI experiences. And this life cycle includes three main iterative steps. We have the design, the discover phase, which is all about understanding the business needs, make the hypothesis to address it, and identify the right large language models that fit the scenario, and also iterate and test over prompts to make sure that the model is the right one. Then we have build and deploy, which is the core of this life cycle, where we augment the model with business data, we test its groundiness, we evaluate the overall app, and once we are satisfied with the evaluation results, we deploy the model. And we move to the final stage, which is the operate stage, which is about operationalizing the app deployed on the cloud, applying safety system, and make sure robust monitoring is in place to handle exceptions or regression. And this is not a linear process. Each step might be repeated more than once. So you can go from left to right, but also from right to left, because in some case, you might need to go back and test again your app with a different model, a different prompt, or a fine-tuned version of your model, and so on and so forth, in a continuous improvement cycle. Okay, so you have multiple options to build an agent in the Microsoft ecosystem according to the level of flexibility and ease of use tools you need for your project. These are the three main approaches. Infrastructure as a service approach is the one that allows maximum customization, degree, and control visibility over your solution. So you build your agent with a framework of your choice. The recommended option by Microsoft is the Microsoft Agent Framework, and Jose is going to talk more about it in a moment. We have the platform as a service approach, which is kind of a sweet spot between a good degree of flexibility and control, but also lots of pre-built features available via a UI or an SDK that make it easier to build and manage your agent. And this is available through the Microsoft Foundry agent service. And I'm going to show a bit more in a moment. And the third approach is the software as a service approach, which is the easier to get started with, as it requires low or no code, and you don't need to manage the infrastructure or Azure resources behind it. Of course, the three approaches have different level of, as we said before, different level of flexibility and control. For example, with Microsoft Agent Framework, you have full control with tool calling and orchestration. With Microsoft Foundry Agent Service, you can choose your AI model. With Copilot Studio, everything is fully managed. And similarly speaking for the conversation thread storage. Pricing is different, and so on and so forth. This is kind of a recap of the main difference. But what I want to say is that they are kind of complementary option, as you can build locally with Microsoft Agent Framework and then scale into cloud with Microsoft Foundry, or import a Foundry agent in your Microsoft Agent Framework code for further customization, and you can then publish your Foundry agents to Microsoft Copilot, Teams, and beyond. So it's not black and white choice. You can also use them as complementary options. Okay, today we're going to focus on Microsoft Foundry and Microsoft Agent Framework. I'm going to cover Microsoft Foundry more in details, especially Microsoft Foundry Agent Service. But just to kind of explain where Microsoft Foundry Agent Service is placed in the Foundry ecosystem. This is the whole Microsoft Foundry platform that basically support you in the whole end-to-end development lifecycle I've described before. So from model discovery with Foundry models, which is an extensive catalog of large language models, to customization with tools and knowledge via Foundry IQ that build your knowledge for your agent, to operating the solution in production with Foundry control plan that gives organization unified visibility and control across every agent. Okay, so Foundry Agent Service, which is the enterprise-grade platform for building and deploying AI agents at scale in the cloud. It's designed to be open, secure, and deeply integrated with Microsoft ecosystem. At the foundation, we have three essential components: models, memory, and tools, which are the components of the agent we have seen before. By using Microsoft Foundry, you can build two types of agents: declarative agents, which are single prompt agents, and you define what they should do in a simple declarative way, natural language. And hosted agents, which are for production-grade scenarios. So you basically have your agent deployed in a containerized app. And for more complex scenarios, Foundry supports multi-agent workflows as well. Okay, so enough talking, I would say. So I want to jump now in Microsoft Foundry and showcase to you how to get started with building an agent in Microsoft Foundry. So first of all, one of the main updates that have been announced and released in November for Microsoft Ignite is a new Microsoft Foundry UI that you can access, which is kind of recentered around the experience of building an agent. And you can access first of all, you can access Microsoft Foundry navigating to ai.azure.com. And then to switch to the new experience, you can just click on the Start Building button in the banner at the top. And then I have a few projects here, but if you're starting from scratch, you are going to create a new project, given your project a relevant naming, choosing the subscription, creating a new resource group to host your resources, choose the region, and so on and so forth. In the region choice, make sure that the region you choose has enough model quotas for the models you want to work with. So I have already a project, so I'm going to select the project I've created for this demo, so we don't waste time with setup, and we start building our agent in the new Microsoft Foundry agent experience. So this is the new Microsoft Agent, the new Microsoft Foundry experience. Here's my project details in here. I can click on Start Buildings and create my agent from here. I'm going to create an agent for managing the expenses of my company. So I'm going to name it Expenses Agent. And here's the playground. If you work with Microsoft Foundry beforehand, you might be familiar with most of these things. The first thing you want to configure here is the model, which is we say the kind of the core or the brain of the agent. I have GPT-4.1 mini in here, but I can I can deploy any model instance available in the Foundry model catalog, and then switch from here very easily from one model to another. Then I need to give my agent some instructions. So let me find those. For my expense agents, I'm instructing this agent to act as an AI assistant for corporate expenses that answer questions about expenses based on the expenses policy data. And if a user wants to submit an expense claim, it needs this agent needs to ask for some input, for some details like email address, a description of the claim, and the amount to be claimed. So it can provide a file that the user can download. So the other thing we need to configure for the agent are tools, we said. We have here, I'll show you, we have here a few tools to choose. For example, you can go with file search if you want to enable the agent to retrieve relevant data from files. HOA search if you want to use, a built-in vector database. You have web search if you want to search data from the web, SharePoint, and so on and so forth. I'm going to add a couple of tools. One is Code Interpreter, because I want to enable this agent to not just generate the code, which is a capability of most large language models, but also to execute the code it generates into a Python sandbox environment. And then the other thing is I want to use file search to upload some files to give my agent some context about the task to accomplish. And this file I'm uploading is basically an expense policy doc, very simple, with a few expense categories and some limit per trip or per day, and some additional guidelines. So I want my agent to be able to access this context data. So I let me see where I have those. Sorry for that. Should be here, and then here, expense policy. Here we are. So I find the doc I want to upload from my local folder, and then I upload it in here in Microsoft Foundry. And as you can see, the file search tool it is creating a vector index on top of the files I'm uploading in a way that I can use the system can use vector search on these data to perform a more accurate search. So now, if I test my agent, which is again made up a model, instructions, and tools, I can test a simple prompt like this one. What's the maximum I can claim for meals? And I expect my agent to be able to answer with an appropriate response grounded on the instructions and on the data I have provided. In fact, it is answering that maximum you can claim for meals is $50 per day. And not only that, it is also adding the reference to a file, the file that I've uploaded. In this case, I've uploaded just one file, but if I upload more than one file, this is very helpful because the user can kind of validate the data the response of the given by the agent with the data provided. And now let's go to the next step where we ask the agent to do something like submitting a claim for a meal. So I want the agent to help me to submitting a claim. And as instructed by myself before in the instructions, it is asking me to provide an email address, a brief description of the claim, and the amount I want to claim. So I'm going to provide, first of all, an email address. And then I expect the agent to ask me for the other information. And that's what it does. So I'm going to provide the other information, which are the description of the meal and the amount. And so now it should have everything it needs to create the claim. And it is asking for confirmation. So I say yes. And I wait for it to actually perform the action. So create the claim submission. So as you can see here, it is using the code interpreter tool. So it created the code it needs to write the details I have provided for the meal submission into a TXT file. And then it executes this code in a Python sandbox environment to actually provide me with the output file that I can download and open here to see the final results. Let's open it together so you can see the final output of my expense submission, which you can see is a TXT file with all the details. Cool. So here's my expense agents that I've built in few minutes with the Microsoft Foundry UI. I just want to show you another couple of things. One is you can quickly publish your agent from here to Teams and Microsoft 365 Copilot. The other thing is you can extract the code and also not only having the code, because I say that Microsoft Foundry Agent Service is available as a UI service, but also as an SDK. So here the template code by using the Microsoft Foundry Agent Service SDK. And not only that, I can also open these in Visual Studio Code for the web. And this will create an environment for me to execute the script the code script you can see here. And when I say an environment, I mean I'm going to get a Visual Studio Code image here with my template code and with all the prerequisites, also all the Python libraries I need to execute this code. This will take a couple of minutes, but maybe I can jump back here later to show you when it finishes. Because I want to quickly come back to the slide and clarify. I see some comments in the. Just checking if there's any questions so far. Please feel free to, send in the chat any questions you might have. Oh, yes, Sam, here you are. Hey. Yes. Just really quickly, I just want to, since I've introduced this stuff, I just want to clarify one thing. Again, Microsoft Foundry Agent Service and other services that you might use to build agents in the Microsoft ecosystem are not kind of course, you have options, but you can also, they are also complementary. They are also well integrated together. An example is Microsoft Agent Framework and Foundry Agent Service. These platforms work together to deliver a seamless developer experience, and they run on the same runtime. They run on the same foundation. And so at this point, I'll kind of leave the floor to you. You say, I know you have, you're going to do a deep dive on the Microsoft Agent Framework.
Just a tiny bit.
And all the it is midnight.
All right. Thanks, Carlota. I like how this fits together and how now with this core AI structure in Microsoft, everything is kind of tightly collaborating and integrating together. So the ecosystem is closing the loop, as you would say. So I think it's a nice story. Thanks. All right, the agent framework, my favorite thing after semantic kernel and autogen, of course. So let's go ahead and go talk a bit about what is Microsoft Agent Framework. This is basically a pro code approach, which is open source for building and orchestrating intelligent AI agents. So it's kind of what to me closes the loop. So where does this come from? But before, what is here? What is the promise of Microsoft and what is the reason of this framework to exist? Basically, it's rooted in open standards. It has as well a pipeline for research where we will see in a moment where it comes from, and it's community driven and extensible by design. So, for example, I'm probably saying that there's a Microsoft AI MVP I'm contributing to it. So yesterday, thanks to Ben Thomas, Jacob Albert, and other uh, like Chris Rickman, we manage also, I think Roger Barreto helped me and block a issue that we had. And yesterday we have labels in the workflows. Now, I cannot show that yet but it is already in there in the main repository. And basically, it's ready for production, or the goal is that it is ready for production. It's still in preview. It's meant to go GA in Q1, but it's quite solid. Let's go ahead. So first, it comes from the conversion of two of the best, right? So if you are into Star Trek, you have these phrase which is the best of both worlds. So you have the semantic kernel, which was the GA production ready for companies framework, and it's designed for building AI agents, which is excellent for single agents, and well, can be extended to multi-agents with some integrations that came from AutoGen, but they are implemented in semantic kernel. And then you have AutoGen, which is the ultra experimental framework that breaks every week or so. So everything you build on top of it, you have to keep it up to date, or it will not work the next day. And it's fantastic for getting agents to collaborate together, implementing experimental patterns, and handling complex workflows. So it's pretty cool. And this is bringing them together, which is what the people has been asking for a long, long time, including me. So this is great thing. And also the two teams working together, I think it's a fabulous dynamic. Also, the framework is rooted for standards. So the standards in this case, the top ones are OpenAPI. Of course, that comes from the beginning. All the frameworks and also the LLMs are based on this API standard. Also, they support MCP and A2A, and that's the promise. And new incipient standards. Like for example, one that I particularly like and started to dig in is AGUI. And of course, a lot more things like Carlota mentioned, it's integrated very tightly and perfectly with Azure, sorry, Microsoft Foundry. Um, After Ignite, we should update this slide, and other frameworks, and also graph databases, which are starting to shine for integrating with agents. And of course, we go to the part that I like, which I like to show you a bit of code, right, as we are on the part of building today. So workflows are nothing more than directed graphs, and they are basically a mix of business workflows and agents with which give you as a software engineer or developer full control. You can implement them as well in Microsoft Foundry, as Carlota mentioned, and they are designed for complex business processes and integrations. But I would say they are enabling you to create efficient workflows, make them really useful. And this is where agents shine like humans when we collaborate together. That's what makes them shine. And let's first differentiate what makes this change visible in a agentic workflow. So let's first go to the normal usage of an agent or a chat, right? Which at the end is the same. So you have a task, which is write me a blog post entry about global AI series for LinkedIn in one go. So you start, you put the prompt, you give some context, and the agent thinks and then provides an output, right? And the output may not be what you want. So you have to line it. You say, hey, sorry, I wanted this a bit more fun, more serious. Don't use that much emoticons. Please use these words. I like this and I don't like that. So you make it yours. Unless if you want to generate text with an AI, you can get it what goes out at the beginning, but it will scream, I'm made by AI. So you don't want that. And you have to make it yours. And that's the way you have to line it. It's your work. And um, once you go to agentic workflow, you can have two agents collaborating. So you can give the same task, but you also put a bit the starting draft. You tell it to consider some areas that need revision. You adjust a bit the prompts of the agents, right? What drives them, and you create one which is a creator and the other which is a critic. By the way, this is rooted in a paper called Critic. If you search archive, which is the website for looking for AI papers, you will find a critic agent. I think it's beginning of 2024. There are a few ones about reflection, but it's mostly about self-reflection. And this is not that useful as the critic workflow, which is having two agents, and that adds value. It's powerful because each one has its laser focus. One is to create, it's to write or to code or to do something. And then the critic is to analyze it and say it's good enough for the output, and it has some criteria to determine that. And then it provides feedback to the creator about what to do and how to improve with really accurate suggestions on how to improve. And the creator takes that. And this aligns the creator agent so you don't have to. So it saves you work. And at the end, this will flow several times from the creator to the critic to creator until the task is done or considered as done by the critic. And then you have the final output, which you can guess it will be a lot better than the other workflow, which goes from start to finish, no iterations, and you are doing the work of the critic. So, do you want to do the work or not? If not, you should learn how to implement workflows. So let's go ahead. I have another example, which is from 2023, which is like 2 or 3 or 4 generations in agentic time. And we have the human evil benchmark. And this is a comparison of this human evil, which is a coding benchmark early. This is done by the team of Andrew and G from deeplearning.ai. And GPT 3.5 achieved 48. And of course, GPT 4 achieved a lot more. It was better. But then we apply some techniques of agents collaborating, like basically multi-agent, and they reach 90%. So the lower tier model beats by far the higher tier if it uses workflows properly. Of course, if you do that with the higher tier, it becomes a lot better. So you can see that the difference is no longer that similar, and it adds a lot of power. So coming back to the agent framework, it provides some collaboration patterns like a sequential that is a sequence of steps or nodes where inside of each one you can put code or an agent. And in one, I prepare the information, or I do research. The other, I orchestrate the information, and the next I validate, and finally I present that to the user. That's a ready-made set that works really well. Or the other is concurrent, where you want some laser focus agents to review, for example, on different aspects. I could have the text review by, okay, you will review only if there is PII. You will review if the facts that I state are not hallucinated or they are. And that works extremely well. And other kind of reviews or checks that you want to do, and they happen in parallel. So the time is optimized So when you have to do a task which is timely, this helps a lot. And also it makes sense to do that. Handoff is similar, is one agent that delivers tasks to another. And then we have a group chat, which is when we do a chat and we put several agents that can talk together. And there is more. And there is the workflow process, which is when we mix all these in one. But I say, let's show you in one of these use cases, what not mentioned before, which is a claims process. So I like to show you two small demos. Um, One is the claims intake on the focus on insurance company when they take a claim in. For example, I have here a user input node, which asks the user, hey, tell me something, right? And then it goes to the claims intake executor, which has a claims intake agent. This agent is meant to talk to the user and get details of a claim, and it will not proceed until it thinks the claim is complete, basically. And then it will ask things to the user and fulfill, and for this, it's filling up internal structure. And also it's accessing some tools. So here, this has these two demos I'm showing has an MCP, which they are using as a tool, right? And has a claims validation executor that validates that what the claims intake provider is good or not. Take this as a critic, the critic I show you. So it checks, it gets some extra additional data. It could use a higher end model, and everything here which reaches the next agent is structure input, which is prepared for the claims intake executor. So that means that it will behave in a lot more deterministic than a normal agent, which is a proper technique using structure output. And finally, once this is good, it goes to the claims processing executor that puts everything in a shape that is able to be delivered to claims processing workflow. So let's take a look to it. I have a code here, which I'll share late afterwards. The link to it, it's in GitHub. And I have here this claims intake workflow, which, for example, I'm just in the part where I create a workflow. I'm not going to show more than that. We don't have that much time. So I'm creating here the claims user-facing agent, which, for example, it's here. It's basically the same that you saw before. So I created a chat client agent, and I give it a name and then some instructions. Same as you saw in Microsoft Foundry a moment ago. It asks for claim type, set type, or it infers it, the date reported, etc. And I tell it the goal is to gather information through a normal conversation, right? I tell it the conversation approach, some examples of interaction, and the output format. That's it. And then I give him the tools, right? In this case, I'm using simply some tools that I defined earlier and are provided by here. And then I have the workflow, which is what I showed you a moment ago. Graphs are made of nodes and edges. In this case, the edges in a Microsoft Agent Framework are called executors. If I add directly an agent, the agent gets wrapped in an executor. And this happens here, and this happens inside Microsoft Foundry, always, automatically. So here I add that the input goes to the intake executor, and the intake executor, if it's ready for validation, it goes to the validation executor, which hosts the validation agent. Otherwise, it goes back to the user input exec, which is just asking the user some text in the console, nothing more. So it's very simple. And then the validation executor does its thing, and it goes to the processing executor for getting this process. Or if it is not ready, it goes back. So this is called, it's a switch, right? But at the end, it's conditional edges that one goes back if it's not ready and the other goes ahead. At the end, it's very simple. And then I give it a name, and then I build it. Nothing more, and execute it. So one thing we could do is execute it. Let me move that here. And then I go for the claim intake. And first, I tell it to print the workflow as a flowchart because I'm very visual. I like to see how it works, and then ask you what's going on. We can say my bike was stolen, so this is meant for anything, but mostly the claim processing that I will show you is claims processing for property theft. So my bike was stolen, and present with conversation memory, and now it will tell you, yeah, name, me, and it happened was yesterday. All right. Okay. Noted information. Yesterday, it gets also the tool to check the date. And yeah, stolen bike. It was Hello Kitty. Nice bike. Collectors. Mm-hmm. Full pension. All pink. Clearly recognizable. Stolen. And going out or for lunch. And at 12 hours approx. I forgot about the bike purchase price. Let's see if it goes through. No, how much to finalize? So it remembers. Sometimes it forgets, and then the other agent fixes that and goes back. So that's something good. It is around. So it goes for client's validation. Client's validation is validating, and in this case, it says it's validated and generates a output in this structured format that I printed for you to get it. And this would be started. So and also could provide an email for the claims processing agent to send to the user after reviewing it. So it's still good that humans review what the LLMs have done. Even you have already validated by the claims processing. So, all right. So we go back there. This is what we have seen now in demo. Let's see if, okay. And then we go now to the claims and fraud processing, which is the bit more complex. So what we generated would be the input here. So it would go through a data review, start and conditional. We would go to a classification router based on the type of claims. In this case, this handles only the property theft, right? And there will be a fan out. So we deliver the workflow to OSIT, which is open source intelligence. It will check if this Pinky Hello Kitty bike has been found in any marketplace, maybe even before it was stolen, which would be showing, hey, this is fraud. It checks the transaction for if there is any sign of fraud, like high value, anything that has been done in a way which is not normal, like a very concatenated chain of events, like it's prepared, or check the user history for it. Oh, okay, this gentleman has claimed like 3 or 4 bikes in the last 4 months, right? These kind of things we need to check. And then it aggregates all the information. By the way, I found an issue when developing that I did last weekend. I showed the same demo in a Microsoft session this week on Tuesday. Yeah, the issue was when you access the share state. So you, in a workflow, you can share a state in the different executors. So you can fill in each piece, each agent can fill in its responsibility. But here, if you do that and you access the share in any of the fan out, the workflow breaks and there is no fan in finally. So you have to do that on the aggregator. So you will find that a bit curious, but that's the main reason. At the end, I aggregate, then I go to the fraud decision, and there, with all the information at hand, it decides this is fraud, yes or no. And finally, I present it to the user, which should be the claims agent. And this is an example of a workflow that kind of works. It provides value. It is consistent. It does the task really well. And yeah, it could still be improved. So it's not built for anything but presentation. So it is resilient because of some design choices, like the fan out, like using structure output, but I could have a verification agent on each of the flows and have that verified. That would add more cost, but this would make it a lot more reliable and stable. But so far for simplicity, I have not done that. But still, it's an example of how we are going to use agents in a first efficient way, and in the future, as Carlota said, quite a few million of agents that will be on our workflows. And this is an example of that. And I think it's a pretty valid one. So let's go to the code. I'm going to show the claims intake workflow. Let's accept the fixes. And if we go to the fraud detection building, I'm creating some agents, very easy. And then create, for example, data review agent or create OSync agent. Let's take a look, for example, this one. So it's the same. I give him the tools here. The OSync agent is the same. Open source intelligence. You have to check if the item was found, where it was found, and that's basically it. And at the end, yeah, this is the tools that it can use. So it's basically checking online marketplaces, get customer claim user, and get transaction risk profile. Nothing more, nothing less. I create the executors. Some of them have agents and others don't need them because it's very simple. And at the end, the workflow is, I have this is for rendering only. So I try to put it in a dev UI, which I will show you in a moment. Then I have a data review executor, which expects a data review result. It has a classification executor. And if it's valid, then it goes and proceed and goes on, right? And from classification, it goes to property theft fan out in this case. So it's very clear. And this is the fan out, which is basically from this node or executor, I go to OSINT, user story, and transaction check. And then I go to the aggregator, and the aggregator to the fraud detection, and then to the outcome executor. That generates an email for agent and presents it. And the fraud decision executor takes the decision. This is a fraud, yes or no. But without further ado, let's take a look at how it looks.
We have only 2 minutes left somehow, but I could watch the code for you for hours, I think. We need another session to go for the deep dive. But they shared already also your repos, so the people that can follow up on this, of course.
Yes. Okay. So here is the UI interface. Let me move that here. I'm done in 1 minute.
Sure.
So, and you can see that this is a way where I can see the and debug the models. This is embedded in the Microsoft Agent Framework, and I could execute this. I'm not going to run this because this is not pure agents. So the UI is meant for only agents, and this is mostly executors. So this needs some changes. I created an issue in there, so this is not working. So if I now execute it a bit more, and this will be very fast because you will see how efficient this is. So I go to fraud detection workflow. I will select the high risk scenario with the Hello Kitty Collector's Edition. And then it's doing the data quality review. It's going to the fraud scoring, user story. It did the parallel. It detects on transaction analysis complete, fraud score 70%, OSINT check complete, and user story check complete, which it did some things which were not that nice. And yeah, and then fraud determination, likely fraud, that's the output of the agent presented to the user. And then it writes a nice email for the fraud analyst or agent that's managing this claim, right? And providing all the facts so he can check or tell something to the user or directly call the police in this case, right? So that's it.
That's a purpose for a tool to run something. That's cool. That's really nice. And we are somehow then ready to go for Carlotta and also talk about a little bit of Microsoft Foundry.
Huge thanks to Jose for deep diving into the Microsoft Agent Framework and showcase a couple of kind of real-world examples. So just a quick wrap up, we have seen Microsoft Foundry Agent Service today, which provides managed runtime, hosted agents, memory, and an agent catalog. So provides everything you need to get started with building and deploy and scale custom agentic AI solutions. We have seen the integration with open source frameworks like Microsoft Agent Framework, and Jose has walked through a couple of demos. And I just want to highlight from this slide that agents can be extended with very different tools. We have done a few examples, MCP connectors, built-in Microsoft services like Bing, Azure Search, SharePoint, and so on and so forth. And all of these is wrapped in trust and observability. So things like network isolation, identity encryption, logging, monitoring, and so on and so forth. And we do have a few resources for you to keep learning. First of all, if you want to deep dive into Jose demos, here's the link to his repo where you're going to find the demos he showcased today. And then great devs don't be alone, so make sure to join the Microsoft Foundry developer communities as well. We have a community on Discord where we also host roundtable with MVPs, product groups, etc., and a discussion forum on GitHub. And then we recently built a Microsoft Learn module for you to walk through on getting started with building agents on Microsoft Foundry. So if you want to deep dive on all this stuff, Microsoft Learn, we have a Learn module for you. And finally, we also have an open source course to get started with agent building. So with Microsoft Foundry, with open source frameworks, and so on and so forth, with lots of videos, exercise. So you can really find everything you need to learn more about agentic AI in the Microsoft ecosystem. Well, I'm done.
That's very cool. Thank you very much for your time. It was a pleasure to have you here and also speak about Microsoft Foundry and the Agent Framework. Thanks for the demos. Thanks for coding. And perhaps we need more time next session, not only 1 hour, perhaps a little bit more. But thanks for joining and have a great day.
Thanks, everyone. Have a good day.
Thank you.
Bye-bye.